all participants. This is Safdar Ali Khan, Secretary, SSP Kuwait Chapter. Welcome you to ASSP-KC Process Safety Management Forum Technical Meet 16. And today we have very well spread program agenda. We have all admitted to Zoom's platform. Welcome address. It will be given by our Vice President Majruddin Sheikh. Mr. Jahid Thakur cannot make it for some personal engagement urgently. And then introduction and background will be by Mr. Ujwal Ritvik sir. He is PSM community moderator. We have two presenters today. One presentation is case study on Philip Petroleum Plant Explosion and Fire. They popularly call it Pasadena, Texas, in year 1989 by Mr. Siva Rama Kishore, HSC officer from Alganim International. And there may be some question and answer based on the presentation and self-introduction of new member to the forum. Second presentation, experience sharing to Ir is Human by Mr. Rahul Pateri, who is team lead process safety and loss prevention petrochemical operating plant in Dubai. And we will be also sharing expectation from this PSM forum, what is plus and deltas by Mr. Ujwal Ritvik sir. And then announcement and concluding remark by SSP Kuwait Chapter Vice President Majruddin Sheikh. So I will invite Majruddin Sheikh to welcome address instead of Mr. Jahid.
Thank you, Mr. Safdar. Assalamu alaikum and good evening, everyone. Slowly, all the participants are joining, but it's good to start on time. I would like to welcome all of you to today's event. This is our 16th technical meet. It is really wonderful to go along with all the teams so long. We have just started a few months back doing this, and now we are on our 16th technical meet. And I'm very happy to see that all the enthusiast participants are regularly joining this event. I would like to welcome all of you on behalf of ASSP Kuwait chapter. And more details regarding this event will be given by the person whose brainchild is this event. So I would also like to welcome Mr. Shiva, who will be our first presenter today, and Mr. Rahul, who will be our second presenter from UAE, an expert in this field, who will throw some light on PSM area and improve our understanding and knowledge in this area. So once again, welcome all of you, and let's start with our program. And we'll start with our mentor and leader, Mr. Ujwal Ritvik. Thank you so much.
Hello, good evening, everyone.
Hello.
And
evening,
if you are in other time zone, so a very good day wherever you are. Now, somebody told that when we make one good thing, we make one right thing, and then we move on. We make 1,000 right things and we move on, and we forget that we made that right move. But if we make one mistake and then we try to rectify it, that lives with us for lifelong. If you want to experience this yourself, just try to put your finger on the fire, and you will learn that never again you would try to put your finger on fire. This is how we learned when we were child. So learning from our mistakes is the real learning. However, we have to take another next step also. That too, we have to change something. Just by knowing something, that it is like somewhere something is happening in Mexico, or maybe in Cambodia, something is happening. By knowing, reading in newspaper, watching in TV, looking in social media, that does not call learning. Learning is that after we know that this happened in Cambodia, this is how the accident happened in Cambodia, this is how people died, this is how plant exploded, then we change something in ourselves. The way we look at things, we change our training, we change our procedures, we change our documentation, forms, audit process. Then only we say that we have learned. Many times these learning are forced upon you by way of changed standards or changed requirements from the insurers or from the regulatory bodies. The laws will change. So we are forced to change, and then we are forced to learn. So this is how is learning about. Now, I just wanted to take a few moments because some very good quotes have been sent by my friends, and I was thinking about it. But I would like to spend just uh, 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 mm, half a minute or so remembering a very, very close friend of ours, one of our ASSP mentors, who has been with us since last 20 years, Mr. Ashok Lenka. It is shocking to know that he is no more. He passed away when he was waiting for transplant of his kidneys. So uh, we 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 take a moment's silence. I won't say one full minute, but maybe 5-10 seconds. We keep some so we pay homage to the departed soul. So coming back, thank you for your cooperation. Some of you who may not know who was Ashok Lanka, he has been on advisory of ASSP. He has been one of the elections, or chief election officer, if you say so. Last so many years, he has been technical committee heads for our PDCs, conferences. He held so many responsibilities, and above all, he was our binocular in the sense he was our strategic planner. He has been looking through his eyes, through his help. He has been facilitating these strategic meetings, and he he gave us direction how we need to think next 5 years, 10 years, 20 years. And that's why some of his efforts are here, that we are, even after 21 years, we are live and kicking, and you guys are extending his work. So I'm so grateful to him. I have worked with him all these years, and he was a very ardent supporter of bringing PSM program at KNPC. And as you know, that KNPC has been, uh, you know, flag leader in PSM in the state of Kuwait and even in the region. So he has been instrumental in this PSM process as well. Now, thank you for being with us Mr. Ashok, we will remember you all the time, every time we hold these meetings. PSM Group, we are now, this is 16th meeting, and I'm so happy that the chapter office bearers, they are supporting this, and because of their efforts, without fail, we are having this meeting. Only once the date was changed because of some clash unavoidable, but they try to keep this on priority all the time. And thank you, the chapter officers, that you have supported all the way. We meet every third Wednesday of the month, 7 p.m. Kuwait time, and uh, we try to have three things done. Number one, networking. That's the soul, heart and soul of this program. These meetings, these are networking meetings. Number two, we have a presentation by someone who wants to progress further in this field of process safety, and uh, he or she can present any past incident, because my guru Trevor Clarence, he has always been telling that organizations, they do not own. So we need to keep ourselves reminding every time, even though these infamous incidents like Bhopal or Seveso or Flixborough or Texas City refinery, uh, BP Gulf of Mexico incident. These incidents, they are very famous incident, but very soon they go back in background, and we tend to forget especially the learning part. So we want these to be revisited time and again. And the second presentation that we have in these meetings is by someone who comes with an experience sharing. That means what? This is how he or she failed. That's how what we want to know, so that we can amend our ways of doing things. We can change ourselves. We learn from his experiences or her experiences. This is what is the second presentation about. So this is what we take about an hour and a half every third Wednesday. And I request all of you, wherever, whatever you are doing, even if you are a civil construction person, you can think of contributing to this. You are very welcome to make a, to give a presentation. It need not be a PowerPoint flashy presentation, but it can be just simple. You can read out some paragraphs, you show some PDF pictures, and that would be good enough for us to understand. And many mentors are around that can help you making those presentations. It doesn't matter whether you are a safety officer, a safety supervisor in a road safety, in a road maintenance contract. You are always part of process safety. It is such a wide and big field. I keep on telling, it is not a complicated business. Process safety, many think that it is very complicated. It is only meant for some very, it requires very high degree of understanding and all. No. It is something around us. We are always part of it. Even if you are having an emergency plan at your place, and you are, as part of running, as part of that plan, when the siren sounds, you leave the place. That means what? You are a process safety person, because you need to know something already about how to leave the place in a safe, sound manner. also you have an opportunity to improve yourself. What that leaving, leaving, having a safe egress. That means what? You are already in process safety management. Emergency response is a huge part of process safety management. So many people, they think that no, process safety means what? Means I need to know instrumentation, I need to know controls, I need to know calculations. Not at all. It is a very wrong thinking. In fact, those things are required very upfront during design phase. After that, it is just a technician who can scratch the surface of the box, say, where, how do we keep ingress protection, how we keep sparks protected, and the explosion remaining inside the box. A simple technician who does not know what is that box, or maybe due to carelessness, he can ruin a $1,000 box, a protection system, or $1 million protection system, what was designed, and even a 1 second of carelessness, just a scratch from the screwdriver can ruin the entire safety system. And that is why even that technician who is doing maintenance on that box also has to be part of process safety management. So don't ever think that process safety management is something beyond your reach. If you are interested, you are listening to me, that means you are already a process safety guy. And you can, within your sphere, you can improve, you can advance, you can know better. Now, coming to the networking part, we do it in two. Part A is that we get introduced by all those who are joining us for the first time. Although our intention is to get everyone, introduced who are right now in the meeting, but that would take a long time because many a times more than 100, 150 people are joining. So it will not be time efficient to ask everyone to introduce. But we limit ourselves to those who are joining for the first time. And the second thing is that we ask questions. We ask questions, a lot of questions. And the most stupid question, as they say, is the question that was never asked. That is the most stupid question. There is actually no stupid question at all. You need to ask question, you need to comment, because this is networking. So part A is that we will have introduction from those who are joining these meetings for the first time, and part B is that ask question, make comments, challenge the speakers, challenge what they are saying. Challenging it does not mean that you have to be making fun of or being derogatory. No, you have to be civil, you have to be polite, and it is just possible. Many, you know, uh, exceptional experts also sometimes they cannot answer some of the questions. So that's a very good thing. That means somebody will have to research to get answer, and that is even better than answering something wrong or something misleading. Anyway, coming back, so this is what we are expecting. Let me recap. Number one, that we will have two presentations, and we will have networking by introducing those who are joining first time, and all of you who would be asking questions, making comments. Now it's time for me to shut up. What I will do is I would request the first presenter, Kishore, to take over and introduce yourself and then go ahead. You can take about 15 minutes, and then we'll have about 5 minutes of question and answer. If questions are too many, we can, park them for the later period today. So go ahead, Kishore.
Good evening, sir. Thank you for giving me this opportunity, first and the foremost, to be on this platform. So today I would like to present about Phillips petroleum plant explosion. This Phillips disaster was a devastating series of fire explosion which has occurred on October 23rd, 1989 at the Phillips Petroleum Company's Houston Chemical Complex near the Houston Ship Channel in Pasadena, Texas. So we have the images. Uh, yeah, this is before the incident. The first figure we can see before the incident, the plant was like this, and after the incident, the plant got devastatingly, completely smashed up. Smashed up. Smashed up. So we can the initial blast has registered a 3.5 on the Richter scale, leaving 23 fatalities and 314 injured. 185 Phillips and 66 employees and 129 contract personnel.
Mr. Kishore, you have another message. Could you please turn it off or mute it?
Okay. Okay. So events prior to explosion were 3 of the 6 setting legs on reactor 6 plant 5 were plugged on 22nd October 1989. Operations personnel isolated the setting legs according to the site's alternative isolation procedure by closing the 8-inch ball valve, locking them closed, and disconnecting the actuator air hoses. Phillips operations team then contacted the maintenance contractor Fish Engineering to remove the polyethylene logs from each of the plugged setting legs. So the maintenance contractor disassembled the first 3 setting legs and unplugged the polyethylene on October 22nd and started unplugging the 4th leg, which remained a partial blockage of polyethylene, and hence asked for operator assistance for its removal. As shown in this figure, there was a partial blockage. When both maintenance contractor and Phillips operator arrived back at the opening settling leg of the reactor plant operating at normal pressure and temperature, a catastrophic 85,000 pounds of highly flammable vapor cloud explosions at around 1 p.m. on October 23rd occurred, preventing emergency responders to save potential survivors. Ignition happened within 90 to 120 seconds, with the second explosion 10 to 15 minutes later. 20,000 gallons of isobutane storage tanks exploded. Third explosion 15 to 30 minutes later, another polyethylene plant reactor failed disastrously. These explosions' equivalence was a blast wave of 2.4 tons of TNT, resulted in a great loss of lives, property loss worth $1.52 billion, and production halted for several months. Investigation findings were U.S. Department of Labor OSHA investigation report on April 26, 1990, concluded that the flammable process gases released contacted ignition sources resulted in the fire and explosion of this incident. Specific sequence of events was undeterminable by OSHA as none of the personnel who were directly operating the equipment survived the incident of inquiry. The investigation report indicates that the local site's alternative practice for isolating the system for maintenance was inadequate to prevent someone from inadvertently or deliberately opening the 8-inch ball valve during the maintenance procedure, which excludes the probability of sabotage as a cause of its occurrence, similar to Bhopal gas tragedy. Potential ignition sources were forklift, diesel crane, welding torch, cutting, gas-fired catalyst activator, vehicles near polyethylene plant office. Use unconfined vapor cloud moved downward direction rapidly. No process hazard analysis was used in the Philips polyethylene plants. Philips' existing safe operating procedures for opening lines in hydrocarbon service were not required for maintenance of the polyethylene plant settling legs. No provision for redundancy on Demco valves, no adequate lockout tagout procedure, improper design of Demco valve actuator mechanism, an effective safety permit system was not enforced with regard to Philips or contractor employees to ensure proper safety precautions during maintenance, no permanent combustible gas detection alarm system in the reactor units to provide early warnings of leaks or releases. Lessons learned were adherence to safe work practices, process design, operating procedures, and maintenance procedures are linked to an overall process safety and risk management program. A normalization of deviance pursues to achieve an equivalent level of protection must be avoided in any instance. Compliance with standards and regulations. Standards and regulations are to protect workers from what they do not know and cannot afford to learn through experience, as many standards originate from previous catastrophic incidents. Removing or disabling standards. The safeguards are in place for very good reasons, as is documented through layer of protection, LOPA, and IPL independent protective layers. Never should the temporary removal of established safeguards be considered normal, as many incidents happen when the available safeguards fail or are deliberately bypassed or removed. Necessity of crisis management planning at corporate level, value of continual employee training. These are some of the lessons learned in this event, like lockout, tagout procedures, emergency shutdown evaluation, necessity for development of teamwork skills, practice in using EHA techniques, including concepts of inherently safer designs. Finally, I would like to conclude about this particular incident. We will be commemorating this incident in the next 2 days, as it happened on October 23rd, 1989. Another 3 days, we will remember this incident. Thank you, one and all, once again. Thank you, Ujjwal sir and Ramna Garu, everyone, for giving me this opportunity.
That was very well presented, Kishore. Crisp and informative. You covered almost all the salient points. So at this point of time, let us turn over to all those who are attending to put up your questions. You can pose your questions to Kishore or even others who are here. They can also pitch in if they need to, share something similar. So go ahead, ask your questions. Being quiet, as I told, is not an option. So go ahead and make some noise. What you need to do is first you have to mute yourself. Unmute yourself, and then go ahead and ask the question.
I'm Chandrasekhar Sitipalli, ex-KOC.
Yeah, go ahead.
I'm quite familiar with the incident, but this incident was explained very nicely by our colleague, and I congratulate him for that. I just want to share my own feelings and experience.
Wonderful.
This company seems to have offloaded very, very important activities, the core operation and maintenance activities, without much supervision from the owner to contractors. Now, I'm not particularly against that, but I'm just trying to highlight that when such an important and core maintenance and operations are offloaded to contractors, it is very important by the company to train the contractors as a part of onboarding. It is not enough or sufficient just to call a contractor on a tender basis and say, okay, now you are going to maintain this plant or operate this plant, because they will know very little about what happened, what is the history of equipment, what are the safety procedures. So ultimately, as you rightly pointed out, Mr. Ujjwal Ritik, that ultimately the final safety or unsafe activity, whatever it is in the hands of technicians who are going to open the valves or close the valves, who are going to open the junction boxes or close the junction. Very simple activities seemingly, but that is where the final act of unsafe act or safe act, whatever it is, will happen. So at the lowest level, the fitters, technicians of contractors must be trained very well, because maybe yesterday only they were hired by the contractor, who knows. So it is absolutely important that everybody who is operating and maintaining such critical plants should go through a kind of induction, evaluation of competence, and training and onboarding. Thank you.
Thank you, sir. Thank you very much for your kind, sharing. Actually, this incident is an October incident, and that's the reason that that's one of the reasons that Kishore chose this. That we are very close to a very important anniversary in PSM history. Another, why this became so historical, this incident, is because that this was one of the, what you say, the final nail in the coffin for having a process safety management legal standard, which we came to know later as, OSHA 29 CFR. This PSM standard, and as Mr. Chandrasekhar pointed out, contractor management, outsourcing management is a key to the OSHA PSM standard. It's a key element, and as we grow, as the specialization grows around the world, depending on contracted work is increasing all over. So let's go to the next question or comment. Anyone, please come forward.
Sorry, I have one request to other participants. If anyone has faced potentially not exactly the same seriousness, but potentially dangerous incident, working without limited training on an unfamiliar plant, he can come forward and share his experience.
Yes, sir. Thank you. So please come forward.
Sir, yes, sir.
Muruganathan,
That's
you
why.
are there.
Yes, sir. Yeah, that's why, sir. All the companies now the pre-qualified contractor to utilize, sir. While contractor selection and all, the contractor should be a competent than their contractor employees.
Yeah. This one we do. I mean, can you just share how you are doing? You are in a big company, and you are hiring so many contractors.
Yes, sir. Yes, actually, example, sir, in KOC, one project about 6,000 contractor workers are working, sir. When the peak stage of the project, some of the job is specialized. We have to use that kind of contractor only. Example, hot tapping or other critical activities there. We have to utilize that pre-qualified contractors. But sometimes, some companies to get the L1, low value contractor, if they're using, then we have to face that any major disasters there. But we have
So
the contractor
low value
pre-qualified
is high risk.
Yes, sir. Yes, sir. You are correct, sir. Low value, sometimes it is maybe taking to risk, sir. Suppose the person may not be qualified and the competent to meet the requirement of the work, sir, critical work.
Mm-hmm.
And what you are highlighting, sir, sorry to again make a comment, but in my own experience, the most important critical activities happen during turnarounds. And during turnarounds, these additional temporary workers are brought with very little induction and training from abroad.
Yeah, so all of us who are in a position to influence such a act need to act. That's what we call learning. Thank you, both of you. Any other question that we may have? Ramana, how many people we have? Some 38 participants and only some questions, some suggestions, some comments.
Mr. Kishore is there? Dear,
Yes,
the
sir.
pipe reactor have any pressure relief system?
Sir, actually, there is a ball valve, sir. As per my understanding, there is one 8-inch ball valve. That is what the mistake was. Instead of giving any pressure relief valves and all, they they given an alternative isolation system, which is a Demco made ball valve. And during they were removing that, plugging out that polyethylene that formation by the third party or the contractor, subcontractor. This 8-inch ball valve, though it was isolated, somebody was inadvertently, it got opened, and within 2 minutes, it's lots 84,000 tons of this thing was released, sir. This is as per my understanding.
Yeah. Thank you, Kishore. Any other questions? Okay, so possibly now we move on to the next presentation. But before that, let us introduce new participants who are, attending this meeting for the first time. So just come forward and introduce yourself. Abul Wafa Firdausi, is this your first time? You
No,
can
sir.
unmute yourself and just talk.
Yes, sir. Good evening, sir.
Good evening.
I'm not first time.
Mhm. You have joined these meetings in the past?
Yes, sir.
Very good. Yeah. Do you have some questions right now
No, sir.
or something to suggest?
No.
Okay. Who is this Mode Sir? M-O-D-E, Mode Sir. Can you unmute yourself and introduce? Mode Sir. Ramana, you are around?
Yes,
Riaz?
sir.
Yeah. Who is this gentleman? Mode Sir?
Moses, sir, probably he typed it wrong, I think.
Who?
So Moses said, can
Modesir.
you?
Okay,
Yeah.
okay. And anyone you see who is here for the first time? Vishnu S. Who is Vishnu S?
Mr. Madere is. Yeah, Mr. Madere.
Dear all, Assalamu alaikum.
Yes.
Sir, my name is Mehboob Suwani.
Mahbub
India.
Suhani. Yeah.
Yes, sir. Yes, sir. From India. So I am working as a safety officer in Ambuja Cement Limited.
Good.
I have
So,
9 years of experience as a safety officer role in safety solutions. So now here my project construction of cement plant, sir.
good, good. So, how did you come to know about this group?
Sir, recently I was joined, sir.
Yeah. But how did you come to know that this meeting is taking place, or there is a group like this? Somebody
Yes, sir,
told
yes,
you,
sir,
some
yes,
friend,
sir.
or did you see in social media?
Yes, sir, yes, sir. By the help of my social media, sir.
Okay, good. You are welcome, and keep joining every month. And
Sure, sir, definitely, sir.
would you like to make some presentation next month or month after?
Sure, sir, inshallah. I will try, sir.
Yeah. Don't worry. Even if you are not you don't have to make a PowerPoint presentation. You don't have to be very fancy. And if you need any help, there would be people who can help you. There are many mentors in the group. So we expect
Definitely, sir.
you, okay, not in November, but maybe in December, come with some proposal in next 2-3 weeks, and we will help you out. Okay. You can
Sure, sir,
take any
definitely, sir,
past
definitely.
incident and talk about it. That's it. Just now, how Kishore did right now. What you have to do is you have to give a very quick brief. What was the incident and what we learned from that incident. That's
Sir,
it.
actually here there is no incident.
You don't have to talk
Okay,
about
okay.
your incident. You talk about anything you have in the past. You go through internet, Wikipedia. You can go through some other authentic texts and just talk about that.
Sure,
You
sir.
can you
Sir,
can take
actually,
any incident. Even
sir,
you are in a cement. This one, there are many. I know of some cement explosion, cement plant people. They were buried in the silo. I know a long time back there was an incident in one ACC cement plant. There were 2 people who were buried in the silo in the cement because they did not, there was no control again. Possibly there was not much enough control, and these workers were there for cleaning or something, the silo. And
Okay.
somebody dumped by mistake, or we don't know. The whole load of powdered cement was dumped on them. By the time they could be taken out, they were already dead. So talk about something, okay? There will be, you will find plenty of such incidents where we can have potential learning.
Sir, actually, sir, where I worked in past 9 years, there is no, actually, I achieved in the last companies, 0 LTA, sir, where I worked in.
Wonderful. Great, great, great. Congratulations.
Alhamdulillah, I'm telling you, sir, honestly, that is my track record, sir. Alhamdulillah, by the help of execution team and safety team, HSC team. So all the members they have given, helped me also. So I have, that's why that is the achievement, sir. That is my achievement.
Very
So
good. We are
nothing
proud
happened.
to have you. We are proud to have you within us, in our team, in our group, and you are a role model. So we expect you that in December
sir,
you make a presentation.
actually,
Yeah.
Inshallah, sure, sir. I will try my level best, sir. And the second thing,
Right.
sir, here construction of Ambuja cement plant activities are construction activities are going, sir. So I want to need actually, I am interested for land something like that process safety, sir. So I am interested, sir.
Very good. Wonderful. Are there more people who would like to introduce themselves? They are joining. Ramana, who is the gentleman? Vishnu S.
Vishnu is not new, sir. Mr. Vishnu is our member only, but not new.
Okay. Did he join before?
Yes, sir.
Another person I am not too familiar with, Sudesh Kumar Palineswaram. Is Sudesh Kumar. The last name in the list. You know him?
Yeah, he's a old member only.
Uh-huh.
But, he didn't join the audio, it seems. I couldn't able to convert. There is an issue.
Okay. So there looks like that there are not so many new people, but all are welcome. And now let's move on to the next presentation. So can you, this is, as I was telling that normally we try to keep the second presentation with someone who has studied more or possibly have experienced more failures. So one such person is Mr. Rahul Pateri, and go ahead, Rahul, introduce yourself and your topic. You have about 15 minutes, and then we can follow it up with another 5 minutes of question answer. So now it's your time.
Assalamu alaikum and good day to all. It fills my heart with gratitude immensely, especially towards the Kuwait chapter of ASSP for having considered my humble contributions worthy of your time. And more importantly, to just give in my 2 cents to what Mr. Ritwik has already stated. Process safety is more about being aware of the situations, having the enough know-how to look for the hazards, identify them appropriately, and see them happening so that you can effectively manage them. It in my sort of experience over more than a decade and a half in this industry, what I have now come to know and very humble to understand is that process safety is about hazard identification. And to what Mr. Ritwik has actually said in the beginning, very pertinently, is that it is via association, it is via engagement that we learn. And the more we learn, the more we can do this hazard identification. And the more hazards that can be identified, it can be assessed and managed appropriately. And then inshallah, we can, as safety professionals, as cohorts in the major accident hazard industry, we can ensure what now one of our friends just said, zero LTI forever. Thank you, ASSP, for giving this opportunity. And may I please check, is my presentation now visible to all?
Yes, yes, sir.
Yeah, you are very much.
Oh, yes, thank you. So without further ado, I would just like to take it forward. Here, I have been given this opportunity to talk about experience sharing. And the topic that we will be looking towards here is about to err is just human. A little bit about myself. I am Rahul Pateri. I've got a master's in process safety. I've got a working knowledge in functional safety. Like we said, I've got a decade and a half of working in the major accident hazard industry. My career, I started as a firefighter, slowly moved into the EPC business of onshore and offshore. And by the grace of God and the will of understanding, I was able to work as a consultant for process safety hazard industries into consequence modeling and risk assessments, and also run certain computational fluid dynamics. And now presently, having the good fortune of, how do I say, bringing all this knowledge into operations as working as an operator for an offshore and now presently into an onshore industry. Moving forward, we will be looking through the basics. We will be talking about combustion. We will be talking about energy. We will have a little bit about gas turbine and about the crux of the moment, sharing of experience, the failures and causal factors. Like what Mr. Ritwik was stating, it is through mistakes that we learn. Fail means our first attempt in learning. So what is combustion? Combustion, as we all know, it is fuel which gets mixed with oxygen in the ambient. And as it gets some heat, it produces forms of energy like heat and light. Certain examples of combustion are matchstick for people who like campfires and talking over stories and camping. And of course, our bread and butter, which is cooked. So that particular process is also combustion, wherein fuels of various types gets mixed with oxygen to have a flammable mixture, which when ignited gives us forms of energy. Talking about combustion, we cannot do away with what a fire triangle means. What is a fire triangle? A triangle is having three components. So for an effective fire to be generated, what is said is that we need to have, please bear with me so that I can bring in the laser pointer. Yes. So for a fire to happen, we need to have three ingredients, like we said for combustion: fuel, oxygen, and heat. So as per the understanding of fire triangle, it means that for extinguishing fire, if one of these legs are removed, we might not have a fire. So like, for example, if we don't have oxygen, it can be called blanketing. If we remove heat, as we all know, it is cooling. And if there's no fuel, it's called starvation. But then there is a caveat, there is a difference of understanding. Let's see via this example. This is a burning pan for those in the industry and those who have seen in YouTube videos, this is a burning pan. They put in some sort of a flammable mixture, mostly gasoline or diesel. It gets ignited. And then putting onto the fire suit, a person comes up with, let's say, a dry chemical powder and sweeps the fire and extinguishes it. But then may I now please ask a question? How did we extinguish this fire? Because we still actually have oxygen. There is a lot of heat still present. And of course, fuel is there in plenty. Well, there might be some people who thinks that, yeah, well, dry chemical powder removes the oxygen. Well, it's a very good guess, but actually not. So this particular dilemma or this particular question, like what Mr. Ujjwal Ritvik said, it's by questioning you learn. And there is no, how do you say, stupid question. There could be stupid answers, by the way. So how did this actually extinguish? And this went back to the researchers at the day, to come across with something called as a fire tetrahedron. So from a triangle, we started to learn about something called as a fire tetrahedron. So what is this particular thing called the fire tetrahedron, which actually extinguished the fire? It is in fact called as the chain reaction or a chemical chain reaction. So going back to this example and the question once again, how did we ensure that the fire was extinguished? It actually is because while there is fire or there is combustion, along with fuel, oxygen, and heat, in order to support combustion, there is something called as a chain reaction of H plus and OH minus. For the matter of the conversation, let's call it as chain chemical reaction or chemical chain reaction. The dry chemical powder sort of inhibits this chain reaction, and therefore what happens? The fire is extinguished. Let's move forward. So now, once having understood what combustion is, having understood what the paradigms of combustion had been, for example, the fire triangle and fire tetrahedron, now let's come to energy. What is energy? I mean, any higher secondary student or even a secondary student would say that it is the ability to do work. What are the various kinds of energies that we know? We have potential energy, kinetic energy, chemical energy, mechanical energy, nuclear energy, solar energy, and the list goes on. But then let's see this topic or this word called potential energy. Well, for all the safety cohorts or the safety champions in the group and now listening to us, may I please ask, what is a hazard? Well, we know one of the most known ISO definitions, which states that it is the potential for harm. See, potential and potential. What is the meaning of potential? Potential means that it could cause a harm. So what is potential energy? It has energy which could be used. So that is potential energy. And what is kinetic energy? Kinetic, by the word kinetic, means energy in motion. So when any object or any physical entity moves, there is a kinetic energy. Let's look for pictures as examples. So here we see this boy having a ball and having our definition that we have understood potential. This ball has the potential energy. So it is static. It has a potential energy. The boy drops the ball. So the potential energy now gets converted to kinetic energy. Let's talk about an archer. So here in this example, the archer using his bow has stretched it. So it has the arrow over here has the potential for moving forward. And as it moves forward, as the person removes this, the strain on the bow, it has kinetic energy. So now, moving on to chemical and mechanical energy. What is chemical energy? Our human body, in fact, is. We eat a lot of these food. Those food via digestion and hormones get converted to give us ATPs or energy, which helps us to move mechanically. Talking about people, let's look at automobiles. And we all know how the fuel, a chemical inside the engine, gives its a thrust for it to accelerate. So that is a few examples of chemical and mechanical energy. Having understood what an energy is, the various types of energy, let's come to something called as the law of conservation of energy. So again, the vocabulary over here, the conservation of energy. So what will it mean? It means that energy can neither be created or destroyed. It is omnipotent, it's perennial. It can only be converted from one form to the other. It cannot be destroyed. And as something cannot be destroyed, it is not created, but it can be converted to various forms. And it is via this conversion that we have been able to make use of our energy for our daily lives. And something that most of us would know about Newton's third law of motion, which is that every action has an equal and opposite reaction. For example, now a rocket to move forward, how does it happen? It is actually moving forward is a reaction to the combustion of gases and the exhaust propulsion downwards. The flight that takes us places also has these engines which work as turbines to take in air through the inlet. There is a combustion here. It gives us drag, which gives us the thrust to move forward. So moving forward is a reaction to the expulsion of gases. And of course, to all our, for most of us who have been married and having kids, we must have seen our kids watching cartoons wherein the cannon fires and then there is a recoil. So the recoil of the cannon is the reaction to the forward motion of the cannonball. So that's the Newton's third law of motion. Let's recap the basis. I'm sure people amongst us must be thinking, why are we doing this basics? But please stay in with me. It is because the thing is going to come. So we looked into combustion. We looked into fire triangle, fire tetrahedron. We saw about energy, the various forms of energy, and we looked into the laws of motion. Now, let's come to what we all have been waiting for, gas turbines. In the industry, gas turbines are called by various names or synonyms. They are called as gas generators, some call as gas turbines, and there are a few who call them as gas engines as well. So what is a gas turbine? So as we said, gas turbine is something that converts one form of energy to another. And as we've seen in the basics, the law of conservation of energy is that it cannot be created or destroyed, but to make it advantageous for our daily lives, it can be converted from one form of energy to the other. And gas turbine, in fact, converts chemical energy into mechanical energy. So gas turbine is something that helps us to convert chemical energy to mechanical energy. It is used in the industry quite rapidly for generation of electricity. It is used to run compressors, pumps, or any sort of rotating media. It can also be used to propel exhaust gases for regeneration of reactors, for surge control, for so many such wide range of applications so deemed necessary. Talking about gas turbine, there are a few sections of gas turbine. We've got air intake. We've got a compressor. We've got something called as a combustion zone. We've got expansion. And after every expansion, there is always exhaust. So we've got air intake, like any engine, because gas turbine, we said it's also an engine. So in our fire triangle, what did we know? We need to have oxygen or air. So air is taken in. And what does compressor do? Compressor, by the word meaning compression. Compression means to take whatever in one state and compress it. And while you compress it, what happens? Your pressure increases. And for the chemistry cohorts or the chemistry stalwarts in our group, we all know by Boyle's law, when pressure increases, temperature increases. So now talking about our fire triangle, we've got air, we've got a compressor which actually compresses air and thereby increases the temperature. So the compressor gives heat. And then what was needed? It needed fuel to come in. So in this combustion zone, fuel is injected, which we will be seeing later. And it is via the happening of these three together that we get a sustainable combustion, which is then the product of combustion. Those gases expand and send as exhaust. So these are the sections: air intake, which gets compressed, combustion, expansion, and exhaust. The working of the gas turbine, it is just a sort of a pictographic representation of what we just saw. So cold air is taken in, the compressor is started. So we see the cold air gets now pressurized and therefore it is shown to be heated by the color. Fuel gas is mixed. So here what we have as per our fire triangle, we have the oxygen, we have the heat, and we have the fuel. Now, as a spark is generated, it produces a stable flame. And when a flame happens, a flame is a combustion reaction, and it will have its byproducts, which are gases. Those gases which when released from high pressure goes to these turbine blades. These turbine blades, because of the propulsion of gases in a particular angle, so defined by the machinists of the turbine, it now provides a rotary motion or a mechanical motion to the shaft. So like we said, a gas turbine here converted a chemical energy to a mechanical energy via means of a shaft. And here, if you put in a generator, you'll have electricity. If you put in compressor, you can compress. You put in pumps, you can pump liquid. And then even if you don't have a shaft, using exhaust gases, you can actually use this energy for heating or any sort of this media. Quickly moving by, the air that comes in has to be uncontaminated. And therefore, you've got filters, and these filters have something that we call as a delta P. It's a differential pressure gauge which looks into, and if there is, how do you say, a reading exceeding the normal, which means that these screens or these filters are trapped. PT is called a pressure transmitter. TT is called a temperature transmitter. And there are more instrumented protection controls. For example, there are pressure and temperature sensors at the compressor. Why? Because just to ensure that there is enough temperature and the pressure is not too high. There is, of course, a fuel gas ratio and mixing sensors at the combustion side to ensure proper combustion. There is something called as a flame stability by means of an optical flame sensor. It looks into how your flame stability is. Your speed and RPM is checked. There is something called as a surge protection. There is blow-off valve. There is condition monitoring and all those good things which potentially provide an opportunity we can discuss later. So now gas turbine, how will it look in the field? In the field, it will look something like this. It could look something like this. Pictographically, it could look something like this. And so now What is the difference over here? If you see, it's all in an enclosure. And these enclosures are actually acoustic enclosure because there's a lot of noise generated as part of this medium, because the RPM, the revolutions per minute, can be as high as 4,000, 5,000 RPM revolutions per minute. And something which rotates, we all know, generates sound, and this can generate massive sound, and therefore there are mostly into acoustic insulations. Now coming into something that happened in one of the facilities, wherein one of these generators, where one of these gas turbine generators were used, and these gas turbine generators, the exhaust from these gas turbine generators goes to a heater. This is in an oil and gas installation. And then that particular exhaust gas, having heated up a little bit more, goes to reactor for its purge cycles. So what happened here specifically is that there is something called as a transition piece. A transition piece is just to ensure that the it is something like a vortex cut. So what happens, all these exhaust gases will have various turbulences. And this sort of transition piece makes these turbulent flow to be a laminar flow. So what means is that it sort of disarranges, or it limits the disturbance of flow to have uniform flow to the heater. So here, while this transition piece, or while something was working, the particular operator had a sudden shutdown sequence from the from the gas turbine generator. Why? Because the flame detectors within the enclosure detected hot air. So what means, when a flame detector outside a particular, as we said, there is an enclosure, and when a flame detector detects a hot air, which means that there has been a loss of containment, which means something which was supposed to remain in the turbine went out, which means there's a leak, which is not good. So when this happened, they all went to check what happened. So here in this picture, what you see is this transition piece. So the turbines and all are upstream of this, and downstream is the transition piece. Having closely looked, we saw that there was this particular nipple, and a connection from this nipple had fallen down, and therefore what happened, hot gases were leaking from it, which got detected by the flame detector, because the flame detector also detects IR, infrared radiation. So now, when this happened, the team, including myself, what we saw that there was welding and bracing of this particular nipple. This area, as you see, has been welded, and ideally it is one cast piece, and there should not be welding, because what we all know, welding on a cast piece or a seamless piece means this is the weakest link. So now we went ahead to dig what happened. So this particular nipple that we saw, as per the OEM means an original equipment manufacturer, what he had provided was this nipple, which was snug between these small thin plates. But what had happened is, before an incident, what happened when in these plates had deformed a little, because of which there was too much of stress at these small lugs, and the lugs gave off. When these lugs gave off, there was a high demand from the operator side. So what did they do? They went ahead and they welded this piece, because as this had broken down, they had to weld in. Why? Because only then this nipple will be in contact. But then what happened, maybe because of poor welding or heat treatment process, that weld also gave off. And when this weld gave off, also did the threading fail. So then what happened? We then had a makeshift arrangement, had put in metal plates, and then welded it back again. So something which was supposed to look like this on site was like this. So the investigation team came and said, oh yes, this is a human error. This is a human error, poor workmanship, and that was what led to all the particular things. So here, as we see, as we were saying, there was also some stresses on this particular nipple. Why? Because it did not have sufficient supports given. And ideally, we also saw that in order to keep these transition piece in place, there was no place to actually rotate it. So mechanics used to use these lugs as their hold points to maybe rotate it and fit it for the belt to be placed. So now coming in to err is human. How many times to err is human actually means human error? Let me please raise it to all of us here, irrespective of whichever industry where minor incidents have happened, it always boils down to human error being called as the root cause. I, for one, with my little know-how, don't really think so. Why? Because a human error is a contributing factor, but can never be a root cause. For example, here, a few of the root causes are the operations or the machinists went to do heat treatment on a piece without consulting with the original equipment manufacturer. There was no management of change in place. There was no piping support and stress analysis conducted. If there was a transient analysis performed, we would have known about the king points. There was a design limitation and an operational constraint for this particular person to go and fit this transition piece in place. So like we were saying, a human error can be a contributing factor, but it's not ideally a root cause. Mr. Ujjwal Ritvik actually stated this person's name, calling him to be his mentor. And he stated that people who say that accidents are due to human error is something saying that falls are due to gravity. And it is told by somebody called as Dr. Trevor Kletz, who is known to be the father of process safety. Here we come to our end of this presentation. Credits go to YouTube videos. It goes to references from the internet. I follow something called as a golden circle, the why, the what, and something called as the how. The why is very similar to what ASSP, Mr. Ujjwal Ritvik said, that it is to democratize learning, make learning interesting and illustrative. What will we achieve? By learning, we achieve associations and engagement. And what happens? We will be able to identify hazards better. And how do I do this? I have a YouTube channel called as Loss Prevention Maverick. My peers have said that even if you check Rahul Pateri on YouTube, you will come to know of this channel. In my channel, there is always a portion for gratitude. And here I would like to pay my respects to my father and mother who are still with me. If not for them, I would never have had an opportunity to pursue my career, specifically when I was starting. Safety or process safety was not something very lucrative, but they never stopped me from pursuing my career. And thank God that now I have an opportunity to save lives. And like what Kishore said in his presentation, have an opportunity to ensure that incidents do not happen that kill people. Thank you very much to all for listening to me. Thank you.
Thank you, Mr. Rahul Patheri, for a wonderful presentation and engagement with the audience. Ramana, it seems Ujjwal Ritvik sir connection is lost.
No, I am not lost because I was muted by the administrator.
Oh, sorry.
So
Sorry.
now only
Yes, sir.
I have
The
been
floor is
unmuted.
yours now.
Yeah. Thank you, Rahul. It was very inspirational, and we are thankful that you took your time. So now it's time for questions to Rahul. Anyone who is interested to get his or her questions answered?
Yes, sir.
Like Mr. Ritvik said, there is no bad questions. There can be bad answers. So please fire away. Thank you.
Thank you. Appreciate good evening, everybody, and good evening, my Guru, Jolatik sir, and wonderful presentation, Mr. Rahul. Human errors, yes. I don't know. I never thought. These are actually the thoughts. It comes when we do an investigation for the root causes. Whenever the victim says, I never thought that it would happen. My question to you is with regard to the process safety, you nicely highlighted the human errors. As a human, as a worker, as an expert in the process industry, can you tell us how we interpret with the man and the machine to sail smoothly with the process industry? Whenever we do any process, handle the process like the oil and gas industry, how do we interpret with the man and the machine to prevent loss, to prevent any mishap happening? Thank you.
Oh, yes. I'm sorry, I couldn't really get who asked this question, but thank you very much for the question.
Ramkumar.
So if Mr. Ramkumar, hi. If I've understood our discussion, it was about to explain the association between man and machine. How are they distinct and how do they work together so that we can have an effective process safety management? Am I somewhere close to the understanding?
Yes, it's very true. But we were talking about, you explained about the turbine, and whenever it fails, we always blame humans, right? Human error. I'm talking about how we can correct this human error when we interpret with the man and the machine. This is how I phrased it. Thank you. You're very right. You're very right.
Excellent. Thank you. So now, what we have just seen, human error could be a contributory cause for a lot of matters which my fellow audience here had talked about: lack of training, lack of understanding, lack of induction, unaware, a cultural perception, as in if I do something wrong, a blame culture and all this. So which means to say that man error mostly is a competency issue. And a competency issue can always be addressed by trainings, on-the-job engagements, and by promoting conversations and no blame culture. Whereas a machine all start with what our Kishore actually said, the LOPA principle, wherein we need to ensure that the machine is designed appropriately within the design envelope. We need to ensure that proper basic process control systems are aware so that we can see what are the triggering points before it fails, and it has its shutdown and other controls. But to come to your point specifically, for a machine, designing the machine appropriately so that there is enough interlocks and controls in place, setting up the machine properly so that the machine is then transported and brought to site effectively, site commissioning is done properly, and then most importantly about construction and operations, so that there needs to have enough possibility for the man or the operator to operate the machine with as little engagement as possible, because the more we try to work on something, more mistakes can happen. So having effective design, having more automated controls, having effective site commissioning, operating and maintenance procedures, enough spare in place, and most importantly, training, training, and training. So if a machine is designed properly, effectively commissioned and maintained properly, it will work smoothly. The person is empowered to work on it, and there is no blame culture to report it. As soon as something happens, then they will synchronize and then effectively work so that the human error potential reduces. Am I okay with these? Have I sort of touched the question?
Yes, indeed, very much. You have elaborated very explicitly, and there's no doubt about it. Also, we need to take into consideration about the maintenance part, servicing part, and the frequency of, whenever we talk about the maintenance, what kind of a maintenance we need to look into when we have talking about the turbines. Well said.
Correct.
Thank you very much, Rahul. Good luck. Thank you. God bless.
Oh, pleasure is mine. Thank you. Yes, please. The more questions you ask, the more I know what I don't know. So please help me recognize what I don't know.
Dear, how your presentation you are telling about this is process safety? Are you involved any hydrocarbon, or your presentation look like occupational safety? Can you explain that?
Okay. So here the subject title was sharing experiences, and in process safety management, in one of the elements is incident investigation. So what happens, like when we started this presentation, what we were talking about, or the crux of the thing was, mistakes is an opportunity for learning. Mistakes is an opportunity for learning. We have, and it is via Piper Alpha and the Pasadena incident that happened very close proximities that we have the OSHA. So on that premise, what happens is that in this particular incident investigation, which is one of the elements of process safety, if we do not look beyond human error, and if we dig deeper to find, like what my friend who had asked before, if we do not find what interactions are there with the people, what interactions are procedures with the people, how can people interact with plant, how can people interact with the maintenance philosophies, the operating windows. So the more we investigate, or more we dig deeper than finding human error and then trying to fix the human error, we are actually calling something like the iceberg principle. In the Titanic, if you see the movie and read about it, I'm sure it is not the iceberg above the sea which actually sunk the massive Titanic. It is something which is underneath the sea. So by looking at human error just as the root cause and avoiding all the thing at the bottom, we are only going closer to another process safety incident. A very good question, and I'm sorry if I was not able to make it clear.
Yeah,
is it now okay?
Yeah, thank you, dear.
Oh, most welcome, most welcome. Yes, please, I have all the day. My wife has given me full day today, no problem. Any questions on the fire triangle, fire tetrahedron concept, about why the fire got put off and all that?
Thank you, Rahul. I think there is a connectivity issue again with our moderator, Mr. Ujjwal Rathwik sir. If we don't have any question, we are also looking forward for the participant for a next training session. If someone is willing to give a presentation, they can nominate their names. So we will be giving opportunity to share their experiences and some presentation related with process safety.
Yeah, no, I'm here. If Safdar, if you can hear me.
Yes,
there
sir.
was
Yes.
some minor issue with my earphone. So it's like this, that since we do not have any more questions, we will go ahead to conclude. But if somebody wants to introduce himself once again, there is we can do that now, or otherwise we will go back. Thank you, Rahul. Thank you, Kishore. It was very kind of you that you took time and offered your experience and offered your services. We encourage all other people, participants, to come forward and make a presentation, a short presentation. Need not be a PowerPoint presentation. You can, if you choose, you can just speak. If you choose, you can use a PDF. If you choose, you can use a Word or some website or some video, whatever you like, as long as you are clear what you want to present, what you want to tell. 2 presentations every month. So please come forward. And now we are going to close. So before we close, I would hand over to Mr. Safdar, our secretary. Over to you, Safdar.
Thank you, Ujjwal Rathwik sir. It was a wonderful session itself. And tomorrow we are having a technical meet full day with KUSAT, that is Cochin University, for a technical session. So you are all encouraged and invited to attend this session at your convenience, and make us it's a good learning session itself, and we will be looking forward to welcome you on this. Please look at our SSP WhatsApp notification. You'll be getting information on this. So we will float it again this morning. Next morning, I think, yes, this is safety challenges in oil and gas industry. It is starting from 10 till 5 o'clock wait time, and those who are in India, 12:30 till 7:30 Indian time. So you can follow us, our SSP page and LinkedIn also, and some social media. It is already on there. So please feel free, spare a little time and take advantage of this. Now I will invite our Vice President Majruddin Sheikh for concluding remarks.
Sorry, Sardarji, sorry for interruption. We need to have a quiz.
Quiz?
Yes.
You want to play the quiz?
No, yeah, I want to post the quiz in the chat box.
Okay, okay, okay. There is a quiz posted on chat box. Please spare 2-3 minutes on this question. And then our Vice President, Mr. Majruddin Sheikh, will be giving a concluding remarks. So the questions are already there. Please have a participation.
Yeah, those who are new, can explain something about this quiz, Sardarji. Okay, if you participate in the quiz, we are going to announce the quickest 5 winners. And the second one is all the participants who have participated in this technical meet has to participate in the quiz to get the participation certificate. Otherwise, it's difficult and we are not going to send any certificate. It's a mandatory to participate in the quiz. And
Thank you, Ramana. So I hope each and everyone is able to see this questions or Google link in chat box. Anybody is having issue? It's a Google form. Okay, so I'm sure everyone is getting. Once you finish these questions and answers, you will get a participation certificate in your mailbox. This is what the setup we have. So request all of you to participate. Those questions are from presentation only. Thank you so much, Safdarji, for hosting today, and Ujjwal sir, once again, you spared your valuable time with us. Thank you so much.
Thank you.
Thank you. We would like to see you, sir, for our event also, inshallah. I know the timing will be a little bit different, but whatever time if you can spare.
Yeah, sure, I will try.
Thank you, sir. Thank you so much. Mr. Siva and Mr. Rahul, thanks a lot. Wonderful presentations. Mr. Rahul, regarding fire, don't you think there would be a fifth side or element should be there in this fire quadrant rather than having four?
Correct.
For
Correct.
especially a process industries.
There is, you are absolutely right, because this is actually, as you said, the evolution of chemistry, because from the fire triangle came the fire tetrahedron, then the pentagon, and now we've got the fire hexagon as well.
Yeah, we have six now. Could you please throw a little light on this, so
yeah,
our
sure.
Participant, a little introduction of those two sides, because generally I see in each and every presentation they stop at the four sides. So if you give a little introduction to our participants today, it will be better, something new for many of them. Thank you.
Most welcome. Let me just so so here, like we said, there are various types of fires that we have. And just to come back to the chemistry of fire, for anything to burn, it has to undergo something called as pyrolysis. So what pyrolysis in a layman's definition is? Vaporization. For example, I mean, this is an experiment that we can do outside. Let's take a container of the most flammable fluid that we know, let's say petrol. Take a matchstick and suddenly dip it inside. Dip it inside. It is not going to catch fire. Though the flash point of petrol is actually, flash point is minus 11 degrees Celsius, it's not actually going to go fire because there was not enough vapors that has been generated. To look into a wood that burns. So wood is a solid fuel. Though it is a solid fuel, why does a wet wood not burn as easily as a dry wood? A wet wood has a lot of moisture in it, and the more moisture there is surface tension, and because of surface tension, there is a vapor pressure downwards, which what happens is, when there is vapor pressure downwards, there is no vaporization that happens. So for anything to burn, there should be vapors coming in. And as these vapors comes in, then we call this too lean. What means to say we need to have a flammable mixture. One question that I can ask, in our pipeline, we've got flammable fluids running. It is running through inside the pipeline here and there. There are heat treatment processes happening. There is a lot of heat going in. There are temperature transmitters and all that. But still, why does not something inside the pipeline, though it is operated at very high temperatures, not burn? Something inside a pipeline operating into 180 degrees or 140 degrees. Like, for example, a vacuum gas hydrotreater, if I am not wrong, a vacuum gas oil, the auto ignition temperature is something around 130, 140 degrees Celsius. But it works in more than 230 degrees Celsius and still it does not burn inside the pipeline. Why? Because there is fluid inside, but there is no flammable atmosphere. There is no oxygen inside. So from this perspective, there is no air inside. Correct. You're absolutely right. There is no air inside. So what happens is, from that definition came in this thing called as the fire tetrahedron, fire triangle. From fire triangle, we slowly progressed to fire tetrahedron, where we saw this sort of spontaneous chemical reaction happening, the H plus and OH minus. I gave an example of the dry chemical powder being put off, but now for those in the industry who have known about something called as a clean agent fuel, NFPA 2001, it is like, for example, FM200, Energen, Argon, now something called as Novec, the fluoroketone ones. So what does it do? When there is a fire, it sort of sprays down, and as it sprays down, there is a little bit of cooling that happens because of something called as an inverse Joule-Thomson effect. But what actually happens is it inducts or inhibits the chain reaction from happening. Then this subject of slowly, once this hazardous area classification came in, more of dust handling happened. There were incidents wherein in flour mills, rice mills, there were explosions in rice mills. So then they thought, why did this happen in a rice mill? It is just flour. But then later they came to know that flour is a fuel, and therein came the concept of dust explosion. So in dust explosion, you have the fuel, which is this combustible material. It can be flour, rice dust, it can be sulfur or any of that sorts. There needs to be a heat source. There needs to be, of course, oxygen, or for the matters of the perspective of discussion, air. There needs to be a layer of ignition. So this particular fuel needs to be in a particular layer. There needs to have a congestion, and there needs to have a particular, how do I say, this particular layer has to form a cloud. So these 6 factors then came into something called as a dust explosion. I know I have gone very pervasively, but let me please recap. Like the evolution series, as a baby to an adult and to the grave, the baby of us thought about fire triangle. And then as evolution happened, and when we moved into this clean agent protection media, we came to know about something called as the chemical reaction, H plus and OH minus proliferating, which if inhibited sort of cuts down the flame propagation. Then from incidents that happen across the unbeknownst of locations, flour mills, dust handling, fertilizer mills, silos, and the similar and the like, even in polyethylene extrusion plants, I mean, what Kishore was also talking about. There, because of the dust that accumulated, which got heated up, the layer started forming, there was congestion, and as the cloud came in, one small layer of, and that is called as a minimum ignition energy, that in fact created ignition. So right now, where we say we stand in this hexagon point of view, but then later, with now more advancements in this green hydrogen, blue ammonia, green methanol, and all these things, we will have even more sort of advancements happening. For the people who are interested to know more, there is more research material in CMR, Charlie Mike Romeo. It is a research institute run by certain non-profit organizations which actually talks about it. Because I was recently reading an article about how carbon dioxide, the CO2, is now used to make diamonds. Just think about it, yeah? The carbon from the carbon dioxide is extracted and made diamonds. Sorry, I made a segue. But what I mean to say is that the evolution is happening. Presently, we know the 6 elements, but I'm sure there is going to go more deeper and we are going to learn better. And with such associations like the ASSP and similar, and by engagements and Q&As, we will learn more. Thank you.
Thank you so much for that, because generally, when we are in industry, the hexagon is...
Mr. Rahul.
Hello. Somebody is speaking?
Carry on. I muted Majaji. Thank you.
Yeah, thank you, Ramanna. So thank you for throwing some light on other 2 sides of the fire. Generally, in process industry, you need to know these 2 sides also, because it will help in incident prevention as well as to identify the causes. If you are very much clear, you can see what is the risk in a more perfect manner rather than just having the concept of heat, fuel, and oxygen. So thank you so much for that. Maybe inshallah in future we will have more elaborated presentation on this, that how these other sides are useful in the process industry. So now it's a time for felicitation. I would like to heartily thank both of the speakers today. Wonderful presentations. And for the first, Mr. Rahul, thank you so much for sparing your time. And from UAE, you are giving this presentation. It's really informative. So we hope that in future also you will associate it. Ramana, could you please stay? I will tell you the next, okay? Can I, Ramana? Or still something? Ramana?
Please go ahead, please. Stop it.
Okay, so thank you, Mr. Rahul. I'm sure, inshallah, in future also you will spare your time and we will have benefit of your expertise in this area. And this is just a small token of appreciation from ASSP Kuwait chapter, piece of certificate. Thank you so much for this. Inshallah, in future, we are going to start a meeting together, and we'll surely be in touch with you. Maybe you will join us here in Kuwait personally, and we will meet with each other, and we will have some good sessions from you, inshallah, in future. Thank you so much for today's presentation. And next is Mr. Siva. Yeah, Mr. Sorry, Mr. Rahul, you would like to say something?
Oh, yes, please. I'm sorry, Shiva, for stealing your thunder. Thank you very much for your kind words. I remember something of the sort, when you are ready, the teachers appear, they say. So, and in my sort of, I wouldn't say passion, but my why for engagements is actually to make learning illustrative and interesting. I am very happy that I have been able to give some snippets. And thank you very much indeed. To be honest, my gratitude is towards ASSP for considering me, giving me an opportunity and trusting in my abilities to have so many people assemble and listen to me. It is very easy for me to speak. It is actually very difficult to listen, and patiently listening has helped me and encouraged me for being more. And I am always available anytime, at any movement, even if it's impromptu. I am always available, not a problem at all. More than happy to associate, because I learn by these associations. It's not that I am doing something, it's I am learning. And thank you very much for your kind words.
Thank you so much. Thank you so much for that. Next is Mr. Siva. Thanks. It's nice to hear from you. Wow, that's a good start. And I hope in future also you will come forward and you will give such a nice presentations. Your efforts were seen today, and hope inshallah you will have a good in this area in the future. Thank you so much, Mr. Siva.
Thank you very much, sir. Indeed, I'm really thankful to Ramnagaru and everyone who has actually taught us the process safety. I attended all the process safety sessions which were conducted. I am really thankful that I got a pathway. In fact, through all of you, I cannot name all Mazhar sir, Safdar sir, Ashok sir, Siva sir, I mean Sai. I forgot in a elated mood, I forgot all of these names. But I'm really thankful for giving me a pathway into the process safety. I thank Ujjwal sir and especially Ramnagar, who has introduced me into ASSP. My all gratitude and a lot more thanks for everyone.
Excellent, excellent, Siva. Thank you so much. And it's our pleasure, it's ASSP chapter's pleasure to support their member, to be helpful to their member in any manner it can be. So please feel free to contact us in any area you would like to improve. We have a process safety forum with us, and we have experts in that. You know that you can talk to anyone at any time, and you can be clear of what you want or what you want to learn in the future, and in which area you want to improve, which area you would like to give your expertise to the chapter. All these things are there where you can take benefit or you can give benefit to the society through this chapter. So thank you so much for joining us, and thanks for your presentation today. Now we will have quiz winners with us today. The first winner, the winners are based on the number of answers. Congratulations, Muruganantham. I am very happy to see your name. It's obvious when you are participating, of course, you will be there on this stage. So thank you so much, and congratulations. Congratulations. The next winner is Mashallah, Manzoor Rasuldar. Again, wow, the same directorate. Excellent. Congratulations, Mr. Manzoor. Thanks for joining us. Wow, today all stars names are here, mashallah. Mr. Pravesh, very good friend of mine and very active member of, not only member, you can say a leader of ASSP Kuwait chapter. Congratulations, Pravesh ji, and thanks for joining today. Next. Oh, Mr. Mohammad Muzammil. Congratulations, Muzammil bhai. Thanks for joining. This is cheating. Congratulations, Mr. Siva. Of course, of course. Good to see your name, and thanks for joining us today. Congratulations a lot. So with this, we are ending our event today. Inshallah, I am sure all of you have enjoyed it a lot. And of course, as we already declared that every third Wednesday, we are going to have this event. So in November, also, we will have on the third Wednesday, this event at the same time. And I request all of you to please join us for the event and spread the word for the benefit of others. And also, please come forward for the presentation. If you have something to present on this stage related to process safety, some learnings, as Ujjwal sir always says, you don't need to do so much hard work on the presentations and slides kind of thing. Even if you have some subject which you think it will be beneficial for society, please come forward. And if you want to make something beautiful in your mind, please contact us. We will surely help you to develop, but please come forward and present in this stage. This is not only to develop your process safety skills, but yes, to develop your presentation skills also, which is very much required when you are in the field of safety, whether it is occupational or process safety. It is very much required. So it is not only benefit of society, but it is also for yourself to get benefited and improve your presentation skills. So please come forward. You can send message on our ASSP chapter number or contact me directly or Mr. Safdar. So if you are ready to present in next month or even after that in December. Thank you so much with this, and we are ending. Have a good night. Anybody has any questions related to anything, they can ask. Now officially we are ending this event. We will be here for next 5 minutes for networking. Thank you. Thank you, Ujjwal sir, so much once again for joining us.
Thank you, Majarji.
Thank you, Ramana. Thank you, Riaz. And thanks all participants for sparing their valuable time and joining with us. Thanks for participating in the quiz. And special thanks to Safdar Bhai once again for hosting today's event.
Thank you, Ji. And tomorrow we have this event. Please don't forget, these very nice technical sessions are there. Join for your interested technical session. No need to be online on a whole day. Whenever you require for a specific topic, you can join.
Okay, Rahul is also joining with the other rocking topic also.
Yeah.
Thank you, Najas.
So this event is very, I think we have Mr. Najas with us here. This event is purely his efforts to bring us together with QSET in India, the expert from there, and we are going to have very, very, very informative sessions tomorrow in this event. I request all of you, without fail, take the benefit of tomorrow's event and join it, listen it, learn it, ask the questions, and at the end of the event, I'm sure you will feel that you have got something new. So I request all of you once again, please spread as much as possible. As in this part of the world, tomorrow will be the holiday, so it will not be difficult for the people to spare their time for this. Thank you. Thank you, Mr. Najas, for bringing this on table and working hard to make it successful. Thank you.
Thank you.
So,
Thank you,
Ramana,
yeah,
we can close the meeting and see you all tomorrow at Kuwait time 10 and 12:30 Indian time. Thank you.
Thank
Thank you. Okay, good night all. See you tomorrow. Bye.